Hey folks, Professor Gray here with some bad graphs. Some graphs are bad because they contain errors. They're mathematically incorrect or because the data itself is recorded in a way that is errant. Some graphs are bad because they're technically all correct, but the way they're presented is misleading. And it's important to develop the ability to recognize these bad graphs and identify why they are bad. There's a lot of information out there that is either have errors in it or are presented in ways that can mislead you. So, histograms should have a few things. They should have a title. It should be labeled on both axes. It should be clean and clear and easy to understand. Their information should be accurate, and the data should be at the forefront. The data is really the star. So here's an example of a bad graph. As you can see, the histogram has a title. That's good. But then the axis labels are absent. I don't know what 1, 2, 3, and 4 are. I don't know what the vertical axis is showing either. Also, over here on the right-hand side, I have Series 1. That's a legend. Programs like Excel automatically put those in often. But really, there's no need to use those unless you have more than one data set on the same graph. So that also needs to be taken care of. So here's the histogram with some changes. Again, I've got a title, and the histogram has no gaps between the bars. That was another problem with the first one. But now I've just got this big purple blob. I can't really read any of the bars. The axis labels are also absent, as well as the classes or the category names. Now it's been adjusted. I have outlines on each bar so I can easily read those. And I've got an axis label for the x-axis. The y-axis or vertical axis is still missing a label. And here's a correct version of this same histogram. As you can see, there's a title. There are axis labels that are easy to read and follow. The different classes are clearly marked. All the bars are adjacent with no gaps, and they are outlined so that I can read them. Bar charts are similar. They should have a title, labels on both axes, clean and clear, easy to read. They should be accurate, and the data should again be at the forefront. So here's a bar graph. What's wrong with it? The bar graph has a title, which is correct, but there are no axis labels. And the numbers on the x-axis do not indicate nights of television. I don't know what night 4 is, or 5, or 6, or so on. There's also a legend included on the right-hand side. No need for that unless you have more than one data set. Alright, so now it's been adjusted. The x-axis or horizontal axis now has days of the week on it, so that's easier to read. However, the legend is still present and there are no axis labels. And now it's been changed again. I've got a title, I've got axis labels. The nights of the week are clearly identified, but there's still something wrong. This is actually not a bar graph, it's a Pareto chart. The categories are listed in order from the highest frequency down to the lowest. And there's a problem with that because the days of the week already have an order. They are ordinal data. So ordinal data shouldn't be put in a Pareto chart. Instead, the order that they already have should be the order that they're put in. So once you correct that, you have a correct bar chart with titles, axis labels, and the data organized in a way that it should be organized. Now for Pareto charts. Again, Pareto charts should have a title. There should be labels on both axes. They should be clean, clear, easy to read. And of course, they should be accurate with the data at the forefront. So what's wrong with this Pareto chart? Well, the biggest thing that's wrong with it is that it's not a Pareto chart. Pareto chart should have the tallest bar first on the left and then step down to the shortest. Here it is corrected. Pie chart should have a title, be labeled with percentages on the slices. It should be clean and clear, accurate, and the data should be at the forefront. So here's a pie chart. What's wrong with it? Well, there's no title, for one. Also, there's a use of a legend, which can be problematic if a reader is colorblind or has trouble identifying the colors, or if the chart were to be printed in black and white. That could be an issue. Also, there are no percentages on the slices, and it would be nice if the slices were outlined. Here's another version. Again, no percentages are used, no title is used, there's no outlines around the slices, and the categories are not named. Here's a correct pie chart. The title is clearly spelled out. Each of the categories are labeled on the slices, and percentages are included so that the reader can tell exactly how big each slice is in proportion to the others. The next group of graphs are technically correct, but there's something wrong with the way that they're presented. Here's a bar graph about survey results by political party. What's wrong with it? Well, the problem with this graph is its vertical axis. It starts at 53. If the graph were to start at 0, then you can see that the differences in the bars are not as exaggerated. By starting the vertical axis at a number other than 0, the difference becomes exaggerated. Here's another example. This is a pictograph, a picture made to look like a graph. What's wrong with it? Well, it's actually a bar graph, or trying to be a bar graph, but there are no gaps between the bars because of the dollar bill use. And really, it's too busy. It becomes hard to read because of the inclusion of the dollar bill. Remember, the data is the star. That is the most important thing for your readers to be able to understand and see. The difference in this graph, this is a pictograph, is a little more subtle. These are annual incomes of groups with different education levels. What's wrong with this is that it depicts one-dimensional data with three-dimensional boxes. So if I were to look at the smallest box, 18,734, and compare that to the largest box, it's 74,602, well, the difference is about almost 4 times as much. The bigger dollar amount is almost 4 times as much as the smaller dollar amount. But if I look at the boxes, because they are three-dimensional, the largest box is 16 times larger than the smallest box. This exaggerates the difference in the dollar amounts because they're not in proportion to the money amounts. So now you know how to avoid bad graphs.